53 years ago, 12 men walked on the moon. They planted a flag, grabbed some rocks, and flew home. And we called it one of the greatest achievements in human history. So here's a question almost no one thinks to ask. Why is Artemis heading to a part of the moon that Apollo never once touched? It's not because Apollo lacked the technology. It's not because the terrain was too dangerous. It's because the moon Apollo visited, the one in every photo you've ever seen, was the wrong moon. Apollo landed on the boring half. And the good half? It's been sitting in the dark for more than 50 years. The Artemis program is NASA's plan to send humans back. But calling it Apollo 2.0 is like calling the internet a faster telegraph. It misses the entire point. Because here's what almost nobody tells you. In all 6 landings, across all 12 astronauts, Apollo never once reached the most valuable ground on the moon. They stayed in a thin strip around the middle, the lunar equator, like explorers who cross an entire ocean to a new continent and never leave the beach. The poles? Untouched. And the South Pole in particular might be one of the most important places in the entire solar system. Why? That's what we're about to find out. And when we do, it'll change the way you look at that bright dot in the night sky forever. First, let's be honest about what Apollo actually was. It wasn't really a science mission. It was a demonstration of power, the most ambitious statement any nation had ever made. Picture it. 1961. The Soviet Union has just put the first human into space. America is losing, and the whole world is watching. So President Kennedy stands up and makes a promise. We're going to the moon, and we're going soon. The goal wasn't knowledge. The goal was to get there first, to plant a flag before anyone else could. And NASA pulled it off. Genuinely one of the most astonishing things our species has ever done. But that single choice, speed over science, quietly shaped everything that followed. The landing sites weren't chosen because they were interesting. They were chosen because they were reachable. Flat, sunlit, close to the equator, picked for convenience, not for curiosity. The South Pole, by 1960s standards, was far too difficult to reach, so they didn't try. And for the next 40 years, almost nobody had a reason to care. Until one day, we threw a rocket at it. And what came flying back out of that crater rewrote the whole story. In 2009, NASA did something that, on the surface, sounds almost reckless. They took a spent rocket stage and deliberately crashed it into a crater at the lunar South Pole. On purpose, at full speed. Then they watched the debris. And in that plume of pulverized moon, scientists found something nobody quite believed at first. Water, not a few stray molecules, not technically detectable. Actual water ice, by some estimates hundreds of millions of tons of it, frozen inside craters that haven't seen a single ray of sunlight in over 2 billion years. Let that sink in for a second. There are pockets on the moon that have been in total darkness since before complex life even existed on Earth. Older than every forest, older than the dinosaurs, older than the first creature that ever crawled out of the sea, and tucked inside that ancient dark ice. Now, you might be thinking, frozen water on a dead grey rock. Who cares? Stay with me. Because this is the part that turns the moon from a trophy into a doorway. In space, water isn't just something to drink. Water is, quietly, the most powerful substance in the entire solar system. Here's why. Run an electric current through water and it splits into hydrogen and oxygen. Oxygen is what you breathe, and hydrogen and oxygen together? That's rocket fuel, the exact propellant that launched the space shuttle off this planet. So that frozen water isn't a puddle, it's a fuel depot, an oxygen tank and a gas station, all sitting on the moon, all for free. And that flips the entire economics of leaving Earth. Right now, hauling a single bottle of water up to space costs more than its weight in gold, sometimes far more. Every gram has to be lifted off this planet against the full pull of gravity. But if you can make your fuel and your air on the moon itself, you stop carrying it all the way from home. The South Pole stops being a destination. It becomes a pit stop, a service station on the highway between Earth and everywhere else. Mars, the asteroid belt, the outer planets, all of it suddenly gets a little closer and a lot cheaper. But the ice isn't even the only thing the South Pole has that Apollo's sites never did. Right beside those frozen, lightless craters, something almost poetic is happening. On the rims, the high peaks at the very edge, the sun barely sets. They're called peaks of eternal light, and they catch sunlight for up to 90% of the year. 2 steps away from 2 billion years of darkness, there's near permanent day. Now compare that to where Apollo actually landed. Out near the equator, the lunar night lasts about 14 Earth days. 2 solid weeks of darkness, with temperatures falling toward -170 degrees Celsius, cold enough that a spacecraft's batteries simply give out. That's a big reason no Apollo crew ever stayed longer than about 3 days. Imagine traveling nearly 400,000 kilometers to another world and being driven off by the cold. But on those polar peaks, solar panels could run almost without pause. Steady power, survivable temperatures. For the first time, the moon stops being a place to visit. It becomes a place you could actually stay. Apollo was a visit. Artemis is moving in. And take a look at who's moving in. Every single one of the 12 people who walked on the moon was a white, male, military test pilot. That wasn't a cosmic coincidence. It was the rulebook. The selection criteria of the 1960s quietly shut the door on everyone else. Artemis cracks that door wide open. When humans finally walk on the moon again, this time at the South Pole, the plan is for the first woman and the first person of color to be among them. And that's so much more than a headline. Picture a kid somewhere, watching that landing on a cracked phone screen, seeing someone who looks like them step onto another world for the very first time. Back in 1969, an entire generation looked up and thought, maybe that could be me. This time, far more of them get to actually mean it. But here's where it gets strange. With all our dazzling modern technology, going back has somehow been harder than going the first time. On paper, that makes no sense at all. Apollo's guidance computer held only a tiny fraction of the memory in the phone you're holding right now. By some measures, your phone is millions of times more capable. The spacesuits were marvels of their era, but they were designed for short, careful traverses on relatively flat, dusty terrain. Not for climbing icy crater rims in the coldest places in the solar system. NASA's new lunar suits are intended for exactly those conditions: greater flexibility, better thermal protection, and support for sustained surface work rather than mere survival. So we have better everything. And yet Artemis has stumbled, slipped, and been delayed again and again. Why? Not because the engineering got worse, because the world got more complicated. Apollo had a blank check and a Cold War breathing down its neck. Artemis has budget committees, international partners, private contractors, and a political mood that shifts with every election. A mood that nearly cancelled the whole thing more than once. Which leaves us with a genuinely uncomfortable truth. The moon didn't get harder to reach. Getting humans to agree to go there did. So step back and look at the whole picture at once. Apollo was humanity's greatest stunt, a sprint to plant a flag and prove a point to a rival. Artemis is something else entirely. It's our first serious attempt to stop being a one-planet species. Because that ice at the South Pole isn't a piece of trivia. It might be the single most important resource in the inner solar system. The thing that decides whether humans ever truly leave home or stay bound to this one pale blue dot forever. And here's what genuinely unsettles me. We've known about that ice since 2009. That's more than 15 years. And in 15 years, we have not sent one single living person to go and stand there. We've sent robots, we've sent orbiters, we've measured it from hundreds of thousands of kilometers away. But no human being has ever stood on the rim of Shackleton Crater and looked down into that 2-billion-year-old dark. 15 years. Now remember, Apollo went from the first man sealed inside a small capsule to boots on the moon in less than 10. And this is the revelation that almost every moon story quietly skips. The real reason Artemis matters isn't the moon at all. The moon is a rehearsal. Every skill it forces us to learn, manufacturing fuel off-world, keeping fragile humans alive somewhere brutally hostile, walking ground no one has ever walked, is practice for the place we actually want to reach. Mars. The moon is 3 days away. Mars is months. If something breaks on the moon, you can limp home. If something breaks on the way to Mars, there is no home to limp to. So we rehearse where the stakes are still survivable. But here's the twist that rewrites the entire story. We always assumed Apollo stopped because of money or politics, or because the public simply got bored. And sure, all of that played a part. But the deeper reason is stranger than any of it. Apollo stopped because it had nowhere left to go. It was a race. And the brutal thing about a race is that it ends. The instant you cross the line, it's over. Apollo won. The crowd went home and the rockets went into museums. An expedition is a completely different animal. An expedition has no finish line. It just keeps going. Apollo was a sprint to a flag. Artemis is the first step of a journey with no end. And when the first astronaut stands on the edge of that crater and looks down into the dark, they won't just be seeing ice. They'll be looking at our way out. The only question left is, how far are we actually willing to go?